This microcredential deals with electrical problem solving in agriculture and consists of 5 targeted skills. This targeted skill deals with amperage and resistance. An important characteristic of electricity is amperage or current. Amperage is a measure of how much electricity is flowing. The more electrons that are flowing, the higher the amperage. Using water as an example, think about how much water would be flowing in a garden hose versus the amount of water that flows in a fire hose. The fire hose would move much more water and would represent a higher amperage or current flow. The same is true for electricity. Larger conductors can carry more electrons, while smaller wires cannot carry as many. Amperage is measured in amps. However, small electronics and small systems have very small amounts of flow, and current flow is measured in milliamps. A milliamp is 1,000th of an amp. Residential circuits typically are designed for 10 to 20 amps. Likewise, many circuits in an agriculture mechanics shop would be 20 amps or smaller for most general purpose applications. Welders and large motors will typically use a 50 amp circuit due to the amount of current that needs to be carried. Vehicles, tractors, or other engines will use a battery system that will have lower amperage requirements, although the starter motor on a diesel engine may draw as much as 500 amps when turning over the engine. Most of the time, however, the circuits on the engine will use much less current. Voltage and amperage are closely related. In order to have electrons moving, there must be some force pushing them or moving them along the circuit. The higher the force pushing the electrons or voltage, the more electrons are moving, thus creating more current or amperage. The next characteristic of electricity to understand is the concept of resistance. Resistance can be thought of as anything that opposes the flow of electricity. Electrons can flow through many substances, but some things conduct electricity more readily than others. Electrons flow relatively easily through most metals, but there is still some opposition to the flow. Electrons have to be pushed through a wire or conductor. Bigger wires or conductors have more room and are not as difficult to push electrons through as are smaller wires. In fact, if too many electrons are pushed through a small wire, it gets very hot. This occurs in an incandescent light bulb, where so much electricity is pushed through a wire that it gets white hot and emits a lot of light. Resistance is measured in ohms. The more resistance in a circuit, the more ohms of resistance it has. Resistance is closely related to voltage and amperage. Ohm's law shows that relationship when calculating values. This visual is helpful in remembering that concept. Using the earlier water example, resistance could be compared to putting a thumb over the end of a garden hose. The pressure would go up and less water would be pushed out of the end of the hose. In electrical terms, there would be more resistance because the water flow is being restricted. The pressure or voltage would also be much higher, but amperage would be lower since less water is able to flow. Amperage and resistance, along with voltage, are important concepts to understand when dealing with electricity and repairing electrical equipment. Always be cautious when working around electricity.